Hello everybody and welcome back to Wildcard Workshop. Today we're going to supplement our video from last week that covered replication. We're going to set up a few examples and go over how they're actually implemented. Our example is going to be just a simple cube with a colored material. The cube itself can represent anything from structures, landscapes, actors in game, whatever you're going to be working with. And the color of the material is going to be the data that we're actually passing between the client and the server. I put together several example actors, and you'll be able to download those files to follow along with if you like. The link will be down below in the description. So let's go ahead, jump right into it, and I'll show you how it's done. So if you've downloaded the files that I've included with this video, when you go to look in its contents, you will find a bunch of actors, a couple materials, and a buff, which is also an actor type. If you want to set up for following along with this example, a couple things that you'll want to do is you'll want to come up here to this top bar, click the little arrow down, check Run Dedicated Server, and set Number of Clients to 2. And that'll allow you to see exactly what I'm seeing as I go through this video. You'll also want to take all of these cubes numbered from 1 to 6. You can ignore 0. 0 doesn't actually do anything. But from 1 to 6, just drag them into the map, like so. This is my 1 cube, 2, 3, 4, 5, and 6. And all of these have different replication methods implemented. So a little bit about these files. The 0 parent BP is exactly what it's named. It is the parent class for all of these other examples. And the reason I did this is it allowed me to implement these 3 functions here. And what these do is they set up and they provide the common functionality. So all of these cubes are actually using the exact same functions, just different replication methods for each one. So I'll show you real quick what they're doing. This setup dynamic material function, it will check this variable here, dynamic material, it's a custom variable on the actor, to see if it has an instantiated object in it, to see if it is valid. If not, it will create a new dynamic material instance. And a dynamic material instance is a material where its parameters can be changed at runtime. We will save it in that variable, and then we will set the material to the cube mesh itself. The next function is this choose color function. And the way this works is it actually generates a random color. And this is just for debugging and so that you can see like when the color is actually being selected and whether it's being selected by the server or the client. But you'll see it generates 3 random floats between 0 and 1 and then converts them into a linear color structure or a struct. And then it returns it. This other function, the change material color, actually takes a linear color and then it just sets the parameter, the color parameter, on the material, the dynamic material instance to that value. Now the materials are really simple. If you open up the master, color mat here, you'll see it's just a vector parameter passed into base color, and that's it. And then we generate a material instance to actually be able to modify it. You'll see there it's got that vector parameter in the parameter groups named color. The name is important because when you go to actually set the value, you have to set it by the name of the parameter. We also have this buff blueprint, and we'll go into that one and why it's there as we go through these other actors. The number 1 actor is a no rep actor. This is our baseline. This is what happens when you've got a random value being generated on the clients and the server. This one will show us what happens when we're not implementing replication properly. The 2 is a replicated variable. Rep notify, multicast, run on client, and run on server. Run on client and run on server are unique because in order for these to work, we have to pass the data through an object that is owned by a client. And that's what this control buff is. So let's actually drop into game and I'll show you what you're actually going to be looking at. So you'll notice it's opened up two clients, one in the main editor and a standalone window for it. So you see, these all have a bunch of colors. Okay, this is our baseline. This is the one without replication. And you'll notice that if I swap over to the main editor, it's a slightly different color. Sometimes the randomization doesn't get as random as we actually want it, but as you can see, if I shrink this window down and we actually look at them all, if we actually look at them side by side, so as you can see, side by side, they're a slightly different color. If we were to run this again, they might have greater variance. But the point is, they're not the same color. If we look at this one, though, you'll notice those are the same color. And the same applies to these two as well. These three boxes are the same color on both clients. That's because these three boxes are already implementing a valid form of replication from server to client. Now these other two boxes, though, you'll notice they don't work. They're just black. And that is because they are not doing things correctly. And I'll show you how to fix that. It's actually, the code for it is already implemented in the file. It's just disabled. But you'll see, yep, they're just black materials. There's no color being applied to them. So before we get to those, let's start by looking at these blueprints down the line. So here's our non-replicated instance, okay? Let's go ahead and open up that blueprint. One thing I forgot to mention, in the parent BP, I actually have a bit of code running in the event graph. On begin play, it does the setup dynamic material. That way, all of these instances are getting that dynamic material without me having to redo that code in each one. Now, in the graph of the one no rep BP, you'll see I have event begin play, parent begin play. This is calling the parent event, which is where it's setting up the dynamic material instance. So it's doing that first, and then it's choosing a color and changing the material color. But there's no replication implemented. There's no switch net authority, there's no run on server, there's no multicast, there's no replicated variables, there's nothing. It is doing this on the server and the client instances separately. There's no communication occurring between them. So the result is that the server and the clients are all choosing different colors. And then they're all setting that color that they chose to the material. This is why the two clients are getting different colors. Now our second box, the repvar BP, this one is using a replicated variable. Okay, the way this is set up is on event begin play, it'll call the parent begin play to set up the dynamic material instance, and then on switch net authority, for the dedicated server, it's doing a choose color, and it's setting the value of a replicated variable in this actor. Replicated color. It's a linear color type. So once it chooses the color on the server, on the authority, it will set that value there. If it was a player server or a listening server, a non-dedicated host game, it would run that first, and then it would immediately go into the change material color. Now, since it's the player server, it's the non-dedicated host, that particular variable doesn't need to be replicated for that instance, but any connected clients to either a dedicated server or the non-dedicated server. There's a slight delay just to make sure that there's enough time for it to run on the server in the editor, because they're all starting up at the same time. And then it does the change material color based on the replicated color. Now, this variable is automatically being replicated from the authority to the clients. So, when we go in game, they all end up with the same color once it sets. And we'll take a look at that again really quick. So give it a second, you see it's black, oh, and then it turns pink. And then if we look at the other one, oh look, that one's blue. Much more variance now in that first one with no replication. One's green, one's blue. But the second one, the one with our replicated variable, as you can see, it's the same color. Same exact color. Now let's look at the third one. The third one is our rep notify. So you'll see it's also the same color. The difference between this one is that the logic for setting the actual color of the material is not here in the event graph. You'll see on event begin play, the parent begin play is called to set up the dynamic material instance, and on switch net authority for both dedicated and player server, it just chooses the color and then does this set with notify. This is what happens when the variable itself is set to replication type rep notify. And then what happens here is when this variable is going to replicate, not when it's set, but when it's going to actually replicate to the clients. And this will be more visible in the sixth example, but just remember that it's when it actually goes to replicate that it calls this function. This function will automatically be created when you set a variable to rep notify. And in this function, it just calls the change material color rep notify color gets put into it as the parameter. So you notice there's in the rep notify function, there's nothing to specify, oh, are you a server or are you a client? It doesn't care in this case, although technically it would be more appropriate to do, say, this. And then cut off dedicated server altogether. And the reason for that is a dedicated server has no players. So it does not need to actually change the material color of the box because nobody is going to see it. I can show you that right now. By setting that switch, the end result is the same. The boxes will be the same color on both clients. And there's red. Oh, no, wrong one. So there's yellow. And the same exact yellow. Because neither of these clients are the dedicated host. Now, the player server does have a player on it. So we do want that to get that value and set the material there. But for a dedicated server, absolutely not necessary. Not unless you were going to be doing something other than a visual change with that linear color data. But we already have it set to a variable on the server, so there's no need to actually apply it to the material itself. Now the fourth example, the multicast BP, this is the manual replication of it. We're not using a replicated variable in this example. What we're doing is on begin play, we're putting in a delay just because it showed some of those quirks that I mentioned before about not having a delay on event begin play. This solved them and it actually gets set properly. It was basically like a bit of a race condition that was occurring where the replication here, this function was actually getting called on the server and trying to be replicated to the client before the client had actually even gone through the process of setting up a dynamic material instance. So what this did was it allowed everything to sort of come into sync. And the way that this particular example works is on the server, or the player server, dedicated or player, it'll choose the color, and then it calls this MC color function. And what that is that's this event right here. Replicates from server, executes on all. So it's a multicast event. Takes the linear color parameter and then manually transmits that to the clients, and it runs on the server. Technically, as with the last example, on the dedicated server, we don't need this change material color function to fire, so we can actually just do this, and then it saves a little bit of work on the server. This is more efficient for the server. Now, it's a very, very minor save here in terms of operations, but those add up. Those will add up. So anywhere you can see an obvious, performance adjustment, go ahead and just do it. Now, the thing to keep in mind is, again, it's when it replicates. It's not immediate. Replication is not immediate by default. And we'll see that in example 6. Remember, now we've got the two that aren't working. So let's look at those. So these are all setting up. Remember those 3? You see how that one took a bit of time there. There we go. Took a little bit of time for it to actually change the color. Again, multicasting, replication, it's not immediate. Now these two, they're not working. That's example 5 there and example 6. Example 5 is our run-on client example. So why isn't it working? Let's open it up. Go to the graph. So you notice that use control buff, that's currently set to false. Okay. So what that is going to do is once this actually opens, you'll see there's a small section of the graph that's being blocked off by that variable being turned off. That was mostly just to sort of have to prevent us from having to keep recompiling these blueprints as we're going through this video. Once that opens up, you'll see a bit of a larger graph here. First thing, ignore this part for now. This is blocked off by that use control buff variable that I mentioned before. So just ignore this section for right now. What is trying to run and isn't working is on event begin play. We've got our little delay here just so that we can try and see the change after we've actually gotten into game. Calls our parent begin play function, which sets up the dynamic material instance. And on the dedicated and player server, it is choosing a color, and then it's trying to call the run on client event, ROC color here, to actually change the material. So if you look at this, it says replicated from server, executes on owning client. Well, here's the problem. This cube actor is not owned by a client. It doesn't belong to any client. It doesn't belong to any player. It's just an actor in the world. So this will not actually fire on any of the clients. And therein lies the problem. That's why this example is not working. So how do we fix that? Well, there's 2 ways. One is to actually set the owner of the actor to a client by giving it a new owner that is owned by a client. But that is honestly a slightly less useful version for modding. A lot of the times we don't want that. Instead, What we want is we just want something to give us the ability to communicate between the server and a particular client. And that's what this use control buff section of code that we're blocking off is for. So if I come back here to the default and I set this to true, we save, now this section of code is what is going to run. And what happens here is first it gets the game state. Okay, this function, this pure function right here, this is a base function to the editor. So you can basically call this, the game state actually exists on both client and server, unlike the game mode, which only exists on the authority. We will get that, we'll cast it to shooter game state, and then from it, after dragging on that, you'll use the get all players function, okay? What that does is it'll return the player instances of everyone currently in the game. We'll do a for each loop. It'll iterate through that array right there. And then we've got this function called static add buff. Now the way this function works is it will add, if the buff is not already on a player, it'll add it. If the buff is already on the player, it'll return the instance that already exists. It won't add it again. That's what that static part means, is there is one instance of the buff on the player. And it'll return whatever instance that is, whether it's one that's already existing or if it had to create a new one. Now, we don't have an associated item or a damage causer for this buff, so we leave those blank. Now, it'll return our instance of the buff. We cast it to control buff so that we can access the variables that we have on it. And if we open it up, now this buff I use for both examples 5 and 6. So there's 2 sections of code running in here. But if you come down here to the variables, you'll see there's the ROS box and ROC box variables. On the 5th example, the run on client, we set the variable for ROC box to this actor, this run on client BP instance, okay? And that's all that does. Now, on the control buff, on the control buff, once it's created, slight delay, it gets the owner controller, it enables input. This is how we can actually set this little section right here. This is used for example 6, but we're enabling input on this buff so that we can use key press events. And then on the dedicated and player server, we choose the buff color, and then we are calling ROC buff color. And that's right here. And this is for our 5th example. We have a short delay just to make sure that the actual box, the run on client BP instance, has enough time to set up its dynamic material instance before we're trying to change the material color on it. After that short wait, we get the value of ROC box, and we try to cast it to the run on client BP class. Or we try to cast it to a run on client BP object type. Once we get that, we'll call the change material color that is part of that class. If you drag off here and you hit change material color, you hit change material color, it'll show up in the list. But if you just right click, it's not going to be there. It's part of that object. So you have to drag off of the instance of the pin, cast as that type in order to access it. And then we'll pass it our color from the server that has been replicated to the owning client. Now the buff itself is owned by a client because when the buff gets attached to the player, the static add buff function sets the owner to the player, And the player is owned by the player controller, and the player controller is owned by a client. So by transitive property, this buff becomes owned by the client. So now this replicated from this run on owning client event will fire on a client. It'll fire only on the client that owns the buff. Now if we run this, since I enabled that use control buff variable, that section of code will run and the control buff will get added to the player. So now we should see a color being added. Oh, look, it's blue now. Uh-oh, what happened here? It's green on this one. Why are they different colors? We're replicating it from the server. Well, remember, we're replicating it from the instance of a buff. Okay, so here's what happened. When we added that buff, we added it to each player. Each player has a separate buff. On each separate buff, it is choosing a new color. Each buff is picking a different color. And because the buff is setting the value on the client side for that material color, each client is seeing a different color on the box. So that's interesting, right? You could actually use that in some interesting ways to give differences in the way that players will see objects. But in most cases, we don't actually want that. To solve that problem, all we would have to do is have the instance of the box itself choose the color and then pass that to the buffs. So we could do something like this, right? We could call choose color. Oops. Oh, hold on. Bad me. This would have resulted in the same problem. So what we'll do is before the loop, we'll call the choose color. Then to the loop. Break that because we don't want it looping. We don't want the execution looping back like that. That will result in some errors. And then on the control buff, let's add a new variable. Call it color from box. We will set it to linear color. And I'm actually going to set it to replicated. No, I'm not. No, I'm not. Because it's only going to be used for this one. So color from box. We've got that variable now. We'll recompile so that it becomes accessible to other classes. Come back to our run on client BP. Now we'll drag off of this. We'll find our color from box variable, and we're going to set it. I'm going to drag from here down to over here. So now, every time this buff gets added to these players, they should receive the same color in this variable. And then all we have to do is remove that function and feed the variable into our run on client event. Drag that there, and then we save and compile. And then save and compile. Now if we play, we should see the same colors on both clients. Give it a moment to run through. Okay. That one's got kind of a tealish cyan color. And so does the other client. So now they're the same. Same color on both. Okay. Now on to example 6. This is another one. It's not working right now. It's a problem. Again, I have that use control buff function because remember we're using the buff for both examples. And the way that this works is it's trying. So this section of code is currently being blocked off by the use control buff variable, so ignore it for now. What this is trying to do is on begin play, after setting up the dynamic material instances, on the client, it is trying to choose a color and then call the run on server event to set the color to the material. And then on the server, trying to multicast it out back to all the other clients. The reason it's not working is, again, this actor is not owned by a client. So we again need to use another actor that is but owned by a client as a means of communicating in that restricted scenario. So we have our control buff again. So this will not fire because the object is not owned by a client. So by proxy, this ends up not getting called in this scenario. Now, it's the exact same bit of code up here that we saw on example 5. Grabs the game state, casts the shooter game state, gets all the players, and then for each player, it adds an instance of the control buff and sets the ROS box value, the run on server box value to this instance. So if we go back to the control buff, it does the same thing. We're doing the delay, we are setting input, and then this is getting called for the example 5. So for now, go ahead and ignore that section. That's getting it called for example 5. This is for example 6. So we've enabled input. So the idea is that when I press Y, it should choose a color, call a run on server event that passes the linear color value from the owning client to the server, and then here it grabs the value of ROS box, the reference to that, to example 6's actor instance, casts it to that type, and then tries to call the multicast color event from external. Now, ignore this section for now. We have we enabled it? We have not. So that's why it's not working. We have not enabled the control buff. So right now it's still trying to use this method, which isn't going to work. So let's enable the control buff. And let's take a look what happens. Now they're all setting up. They're all good. That one's going to take a moment because of the way we set it up. This one though, if I press Y right now, it shows a color. You saw it flash in the top left. Do it again. Oh, there it showed. But you notice that took a while. Okay? But I can sit here and I can pick colors kind of slowly because of the way that it's set up. And they will replicate out to the clients because it is going from the owning client to the server, and then the server is passing it back to all the clients. So this is a user input scenario where the user has chosen a bit of data, and then we want to pass that to the server for everyone else to see. See, it's updating there. But you'll notice if I sit there and spam Y, you can see the colors rotating up there in the left-hand corner. It'd be easier if I did that. So you can see them there. The colors are shifting, but it's not updating. It's just kind of going every once in a while. This shows you what I mean about replication not being immediate. We're just spamming it, and then the replication process is not taking effect for a little bit. So it's just getting the most recent one. It's going through all of them, but it's just getting the most recent one is the last one that we're seeing because it's happening so fast. All at once. So how do we fix that problem? As you can see, yep, they're the same. So how do we fix it? Well, that's what this other section is for. Let me come back here to the control buff. In the defaults, I have set up a variable. It says should immediate update. So we're going to tick that on, and I'll show you what it does. All it does is, after pressing Y, it chooses the color, and then it calls the run on server color buff event, but then it continues on. If that should immediate update variable is true, then it calls the force replicate now function. And what this does is it signals update now. Just right now, call those, do all of your replication on this actor. So now we're saying, okay, immediately call this event. It gets called, it does its stuff, and then again, we've got it blocked off by the should immediate update. After it calls that MC color, remember, this is a multicasted event on this actor right here. It's this function that we're calling right here. Now, after we call that, we're continuing on, and if the value of that should immediate update is true, we're calling force replicate now again. So we are forcing replication from the client to the server immediately, and then we are forcing replication from the server to all of the other clients immediately right afterwards. The result is this. You'll see it's black again, but if I hit Y, oh, that was fast. And then I can just sit there, and every time I press it, it is immediately changing. We are forcing those updates to happen immediately. Now, the thing is, use that sparingly, because we're not just replicating that one value. We are replicating every single thing that is set up, that is currently in queue for replication. All of those, any replicated variables on the actor, any other replicated events, they're all being forced to happen in that immediate instance. So chances are, even though I am only seeing this color change, there may be other variables on the buff that are set to replicate that are also being forced to unnecessarily replicate down. So use that force replicate only if you actually need it. If you need an immediately visible, tangible change, you can do that. And if I actually come over here, if I drag this over here, and I'm looking at it, okay? So we're seeing the same box, that pink one on the right there. And this is the window that we're controlling right here. If I press Y, look at that, it's immediate. You see it right away on both clients. Now, obviously, network latency in the actual live game does play a factor here. There'll be some latency between when clients see it, but as you can see, that replication is actually initiated at the same time for all of them in relation to their own network speeds. So there you have it. I've shown you the 6 major forms of replication in UE4 and how they apply in different scenarios with the same structure. Remember, these boxes can represent anything. They can represent structures. They can represent landscape. They can represent other players, actors, creatures, whatever. Anything that is or is not actually owned by a client. If it is owned by a client, then you don't have to use something like this control buff. If it's not owned by a client, then you need to create some kind of medium, or you need to set it to being owned by a client. And then the data is that linear color struct that we are passing from client to server in each of these scenarios, or from server to client. So, if any of you were unsure about replication before, I hope things make a lot more sense now. Like I said, the files from this video are available for download down below. Go ahead and grab them, experiment. One of the things that I find the most helpful when trying to learn something new is to sit there and push its boundaries. See at what point it stops working to see how much leeway I have to work within a system. As always, if you have any questions, go ahead and post them down below, and I will try to respond to those. Next week, we're going to dive into working with setting up INI configs to make your mods a bit more scalable so that players can adjust them to fit their specific server environments. As always, happy modding!